Hi guys, today we will talking about the problem of greedy police in the reinforced learning algorithm. To solve this problem, I preloaded the memory for the reinforced learning agent. Let's see how it works. I'll just run the script and we will look at the console where states and rewards are created. Now let's look at this problem in detail and write some code. Reinforcement learning faces a critical challenge known as the exploitation dilemma. This dilemma emerges from the balance between exploiting known actions and exploring new possibilities. Choosing action with proven immediate rewards may hinder the discovery of new potentially more rewarding actions. On the other side, trying unfamiliar action to discover outcomes involves uncertainty and may not provide immediate rewards. Recognizing and navigating the exploitation-exploration dilemma is vital in reinforcement learning. Achieving the right balance between exploiting known action and exploring new possibility is a key for efficient learning and the discovery of optimal strategies. I wrote a function that shows how this policy works. Red dots are random actions, and green dots are actions that the algorithm takes after gaining a certain amount of experience. As you can see, at the beginning we have almost all red dots. This means that the algorithm makes decisions randomly. Then the algorithm begins to analyze the decision made and we get more green dots. This is when the algorithm makes a prediction. As you can guess, the process when the agent finds the optimal policy can be very long. In addition, we have many problems before the algorithm begins to understand what happens with the data. In reinforcement learning for trading, the label triple barrier method plays a critical role for pre-labeling data points, expanding the agent learning process in the financial market. This method employs a triple barrier approach defining profit-taking, stop-loss, and time limit barrier around each observation. By customizing parameters such as profit-taking levels and time limits, the method allows for efficient training of reinforced learning agent, providing quick identification of potential trading opportunities. This structured labeling strategy enhances the agent's ability to make informed decisions, adapting dynamically to diverse market conditions and trade preferences. New files with name preload memory inside my agent folder. Let's do a review a couple of methods. The first method would be triple barrier. This is a simple method. We input some piece of data like temp, and another argument would be parameter. This is a dictionary, and inside this dictionary we have some parameters like upside and downside, for example 1% or half of percent. Okay, let's look at minimum price and maximum price. We defined what is the minimum price and maximum price inside in this temp. Then we calculate what is the current price. Then we calculate our upside and downside. If this event happens, for example, like max price would be more than upside and minimum price would be less than downside, it means the market is volatility inside in this temp. If we define this both cases, it means would be label number 2, and I would like to avoid this situation. I would like to change the situation when inside in this temp we achieve some upside. It would be return 1, it would be buy. In another, if minimum price would be less than downside, it would be -1, and it means sell. In another situation, it would be 0. It means we should wait or do nothing. Another method labeled triple barrier. We go through loop our data frame and do labeling all these parameters. Next, I load the data and apply this function. As you can see, we are making up our data set. We have events for when an agent needs to buy, when to sell, and when to avoid situation when the market is too volatility. Now let's plot all these events on graph to make sure it works correctly. To do this, let's write a little more code with the plotly graphic library. Now let's look in what happens. You see, for example, I display a situation when we have a sell signal, and I take the first index And you see, for example, the start point and end point. This is our window when we are going to trade, and inside this window we achieve some 1% of downside. So it means we should trade the situation. Let's look at another situation. For example, I take index number 10, for example. Yeah, okay, it's not exist. Okay, it's not correctly. I mean, I log index like this. Yeah, so it's working. Sell, that's 40. Okay, it's working. Okay, let's look in buy. Okay, buy, it's working. Another 30. Start point, end point, it's working. And let's look in one more. Okay, it's working. And another, I would like to look for both. It means when happens in buy and sell. And I saw this data frame. I have only one situation. It means our index would be 0. Okay, you see, start point inside in this. We achieve this situation. I suggest inside in this candlestick. We have big volatility there. Of course, we have big volatility there, and it means I would like to avoid all the situation. Maybe it's something new, but it is another challenge for us. Let's finish today. You can use this approach for deep learning as well. In the next video, I probably show you how I load this preload data to my agent. Of course, I'm working on another my project. Unexpectedly, I discovered a new approach for training models based on deep learning. At the moment, I have high accuracy, and so far I can't find the bug why I get so good results. Thank you, everyone, and see you next time. Bye.